Hello, and welcome to this second presentation in the series on designing and building IT-based media facilities. This presentation will focus on the best practices in project management and outlines an approach that will ensure that you address all of the key questions in your project design. Before you start, it's important to make sure that you have your basics covered. How well defined are the objectives of the project up front? If it's not clear at the start, the project's likely to unravel in the middle. So you want to make sure that you achieve consensus between all of your key stakeholders as to what the core objectives are of your project and what success is going to look like. Once you know what success looks like, it's much easier to build back from that and understand what it is that you need to do to get there. It's also important to understand the level of maturity of the team and the level of maturity of the organization as a whole. Have you already implemented a similar system to this, or is it the first time? And what are the strengths and weaknesses of the team? So this will set you up to understand perhaps what additional staff you need, what kind of skills you need in the partner you may be working with, or what kind of training that you want to set up. And there are some overall approaches that you need to consider. Are you going to put this all in? Do you have a greenfield site? Or do you have the opportunity to build this all at once as a big bang? Or do you need to work incrementally from a budget or from a technical or an operational standpoint, putting in a piece at a time? Obviously, the project approach is going to be quite different depending on which of these two that you're going to pursue. What is your governance model? You need to look at that very early on. Who are the stakeholders? How's the project going to be tracked? How are change requests going to be evaluated? How are you going to address architectural hurdles? How will the budgets be managed? And change management. Any IT system is going to radically change relative to a traditional broadcast system. And it's going to change job roles, responsibilities, and you need to think through very carefully about how you will do staff management as people change in what it is that they need to learn and understand and how they relate to each other. The approach that we're going to look at here is a 12-step program, and it takes you through design and through implementation. So on the design, this is relatively classic that we have here, we start from a needs assessment and we go through a number of design steps. And the important thing here that we're going to get into in more detail is to carefully separate out functional design about what the system does from the different technical levels of design, the services that need to be provided, the business processes, and the technical. By separating out these layers, you get a better architecture at the back end. At the end of the design, you have your vendor evaluation of who's going to actually implement the system, which takes us through from coding through platform integration and system and then acceptance testing and provision of appropriate training and maintenance at the end. And the two sides of this are also probably best project managed rather differently. On the design side, it's more open-ended, and you may be looking at a more time and materials type approach for this. And certainly you want to separate it out from the implementation that would be best managed on a project-based and fixed cost approach. Let's go into more detail here on those different design components and why you would want to break them up in the way that is proposed here. It's important to not mix these up in a single document because it will lead to errors in architecture. Each of the different design documents that are proposed here address their proper field, and they should be written independently of each other's and independently of assumptions about the underlying architecture that's going to implement them. The first, the functional spec, is all about what the system offers the users. What can it do? It should focus on personas that represent different users and be written in form of user stories, which you may be familiar with from a sort of agile programming perspective. You want to know what goes in, what comes out. And make sure that you cover here not just what the system would do under normal operation, but also how will it react to different types of error cases. And in fact, often it can be just as much work to document well all of the error cases as it is to be documenting how it would work in normal operation. And here it's good also to take in the supervisory functions, so not just the operational users, but also what is it that you want supervisors to be able to see as the system is going on. And the final system acceptance tests should be based off these functional specifications, because this is what the system is delivering to the user. The business process spec sits behind the functional spec, and it's all about how the system's going to deliver the functional use cases. It will be presented as a set of workflows and business process diagrams, and it's going to rely on the services layer beneath it to implement unit functions. So yet again, we want to abstract ourselves at the business process layer from how something is actually going to be delivered, and just talk about the service that is going to be called upon at different steps of an individual business process. At the end of this, also, you're going to define the metadata dictionary. What metadata, both technical metadata and user data, is going to be needed to be maintained through all of the different workflows. The services spec is the exhaustive list of all of the services that are going to be exposed to the business process layer. And where necessary, the specification of the interfaces of each one of these. If it already is part of a manufacturer's API or already part of a standard such as FIMS, then you don't necessarily have to go into all the detail here. Or if the business process manager has already integrated itself with services beneath it, then you don't necessarily yourself have to get involved. But it's very important to know what are the services and what are the interfaces, and if it's a new one, then definitely you have to detail out the interface completely so that someone can code out the service interface. And underneath the services layer is the technical layer. So this is where we finally get to the actual equipment, software and hardware that's going to deliver the functionality that we're looking for. This also has subcomponents, so you've got the infrastructure layer, all of your servers, all of your networking, your storage. You have the components, which are the software and the hardware that deliver functionality, perhaps your MAM, perhaps your transcoders, perhaps your data movers. And in here as well, you're going to be looking at the design of how you're going to implement high availability in the system and how you're going to reach different performance requirements in the system. So out of the back of this is a pretty extensive specification, the technical architecture specification, and a second set of acceptance tests that might be necessary, which are complementary to the functional test, but which are about performance and availability. And the last spec that's very important in these types of systems is the file interrupt spec. So within each service is likely to be calling upon a file, moving a file, acting upon a file on the file system. So it's very important, obviously, that we work with a common spec that every one of the components is capable of reading correctly. So you want to define all of the formats that are to be managed by the system, and you want to go into as much detail as possible, since interop is often broken by small details. It's not enough to say that the reference format is QuickTime or MXF. You need to also define what codec, what resolution, what track counts, what operating profiles to be complete and not to come up with surprises. And it's also highly recommending to have an interop test spec which defines all of the combinations of sender and receiver for a given file. Going into a little more detail now on each one of these steps. So the beginning is the needs assessment. Normally this will be, it'll start out with the business owner, and then it will go into a number of workshops where you're looking at what are the business needs, what are the operational needs, what are the technical needs that need to be fulfilled in order to satisfy the customer here. And you're looking at features, but you also need to be looking at performance, and very important to not just address the conscious needs, the things that people are saying that they need, but unconscious ones. So some of these things are implicit assumptions, and some of these things are more related to base expectations of what people expect to get out of their job. Having done the needs, gone through the specs, you now have to evaluate a vendor. So the first thing is, does it actually conform to the specs? That's the simplest evaluation you're going to do, and that will need to be quite detailed. On top of that, though, you want to know how well will the operational users actually accept this. So there are often, particularly when you're talking about creative tools, a question of users prefer certain systems over other users. You want to look at the API. We're going to be integrating this into a larger system. So how mature is the API? Is it used at other customer sites? And are they using the interfaces that you plan to use? Even better, is it actually used directly within the product? That's a proof of a strong API when the product itself uses it. And what service level can your vendor provide to you? Up front, in terms of their professional services, to what extent are they going to be able to help you in the design and implementation? If development is involved, do they have a dev support service that's going to help your coders? And obviously then support and service behind. And where there is doubt about any of these items, and particularly though the specs and the API, you should consider whether you want to do a proof of concept. So the proof of concept will let you evaluate certain very specific needs that are not clear perhaps at the surface. As we move on to implementation, this becomes a standard project management approach. You want to know who is going to do the work, when they're going to do the work, what are the dependencies, and also to what extent can you automate different tasks. So as we start out with the coding and the unit testing, it's very important to try and bring as much upfront here as possible. Often, as far as testing is concerned, there's a great tendency to aggregate a lot of the work at the system testing stage because you just want to get going. But if you deploy poorly tested unit code, you're going to end up wasting significant resources and platform time that really could be avoided. So try and get as much tested as far upstream as possible and make sure that the system testing only deals with system issues. And once we then get to that system level, the platforms can become quite the bottleneck issue, particularly as the project gets close to completion. Everybody wants to test their last bug fixes, but meanwhile you're performing acceptance testing and you don't want to make any changes. So you need to make sure you carefully consider in advance who is going to be operating on what platform and what your strategy is to upgrade code on each one of them. So more platforms provide more flexibility, but it also means more licenses and a whole lot more work for the system administrator. And this is where automation comes in. Automated upgrades and configuration, you're going to be able to manage more platforms and tighter turnaround times. And you need to think about what types of tests you want to perform on each one. Typically, functional tests can be performed on a very small and limited scale platform, but when you get to doing performance and availability tests, their very nature means that you require a larger scale, and even in some cases, you may need to do this on the production system. And automated testing helps you really deploy this a lot more quickly. As you move to the acceptance testing, it all comes together. You want your platform to be as stable as possible. You don't want changes happening there. And it's obviously critical that you have very clear acceptance criteria set out in advance. What are going to be the tests? What is the test data that you're going to use? Are you going to allow ad hoc testing or just documented testing? You need to clearly define what's a blocking bug, what's a serious bug, and what are the criteria for exiting acceptance tests. Rather than just a sense that it is complete, you want to define this in terms of your blocking and serious bugs and potentially other uptime considerations. In each of these phases, there are going to be critical dependencies that might slow you down. So you want to make sure that you have these covered. On the outside, new features may be required. Maybe your vendor has made a promise that they're going to deliver something. You may be building your own interfaces for certain in-house systems, so you have your own in-house developments, and you need to track those. But equally important are, you're probably more dependent than you realize on operational resources. You need staff who are not directly involved in the project to come to the workshops, to be working up front on the needs assessment. You need them to really review the specifications as they come out, particularly the functional specifications, because they are the ones who have that expertise, and they're the ones who are going to be using the system down the line. You may well want some of their expertise to perform testing, because they're the only ones that are able to do it. And very probably your new system is going to be connecting to existing production systems. So are those platforms available? Do you have test systems for those existing production ones? So how much are you going to be disrupting day-to-day activity, and how can you plan around those connection points to make sure that your new system interacts well with your existing infrastructure? The core focus in a project is usually the feature set, but a significant component of the cost of implementing and supporting a system comes from its maintenance design. So don't neglect to look for ways to optimize this. And this can come in many forms. Automating the installation can save you a great deal of time. Some of these systems can be very complicated. Automating the configuration. A lot of these systems are highly configurable. You don't want to have to do that by hand if you can avoid it. Supervising processes to make sure that you know exactly where a given process is, or that the right people know that. Health monitoring, so that at a glance you can see what is up, what might be down, what the performance is of certain pieces. Make sure that you have system logs that are readable and that tell you important information, so that when a problem does occur, you can find out rapidly where it was sourced from. And test harnesses let you evaluate quickly, if certain problems occur, to evaluate whether different components are working as you expect them to be working. And of course, documentation and training. It's critical to ensuring that the staff can rapidly become effective. Time supposedly gained by skipping documentation is rapidly lost by the same individual replying to the same question n times after you've deployed it. Managing change is one of the biggest challenges in any project, but a few techniques can go a long way to taming this beast. There is nothing inherently wrong with change. After all, our SOA approach is all about adaptability. The key is to ensure that all the changes get the visibility that they need. One thing to do is to make sure that you state all your assumptions up front in the design documents. There are going to be many unknowns at the start that will impact the project. Make sure that you write them up. This way you're going to avoid the "I assumed that" discussions further down the line, which can derail you significantly, and it will help provoke a number of design discussions as to whether these assumptions are valid or not. It's very important to make very liberal use of change requests. So often this may feel like that this is very bureaucratic, to have to submit some paperwork when it's just an obvious thing that was overlooked and you should just put it in. Even if a feature is minor and there's no intention of charging for it, you should document its arrival. It trains teams to always be thinking about scope, and it provides an evidence trail which can actually be quite important later when you want to know why the project's moving off track, and it can help you understand what has driven at least some of that problem. And ask for sign-off. So it's important to help slow down perhaps unnecessary change requests, and it ensures group responsibilities for the ones that you do sign off. So good luck with your project. That brings us to the end of our presentation. If you want to learn more, or if you'd like to have a more extensive on-site training, please send an email to training@macleandigitalmedia.com, and thank you for listening.